Hello everyone. In this video I'm going to briefly discuss about the coagulation cascade. So the coagulation cascade consists of two pathways, the intrinsic pathway and then extrinsic pathway. Let's come to the intrinsic pathway. The intrinsic pathway starts off with factor 12, which gets activated to factor 12A, and this activation is due to factors such as collagen, basement membrane, and activated platelets. So these factors, they just activate this step, but they are not the actual part of the coagulation cascade. So the activated factor 12A will activate factor 11, and then activated factor 11 will activate factor 9. And then this activated factor 9 will act on the inactive factor 10 and activate it. So it is from the factor 10 where the common pathway will begin. Now coming to extrinsic pathway starts with factor 7, which gets activated to factor 7A, and then activated factor 7A along with the tissue factor will activate factor 10, and then the common pathway will start. So the activated factor 10 will activate prothrombin into thrombin. Prothrombin is also factor 2, and then the thrombin will activate fibrinogen into fibrin. Fibrinogen is also clotting factor 1. So these are the common pathways. Now just in addition here, the fibrin that's formed at the end of this pathway, it's a fibrin monomer. So the clot that it forms is a very soft clot. It's very delicate. To stabilize this clot, it will be acted upon by the activated factor 13. So the factor 13 will get activated, and then along with the calcium it will stabilize fibrin mesh, and then forms the hard clot. Now there are very few important points that you need to know here. This step right here, the activation of factor 10 by factor 9, requires a cofactor, which is activated factor 8. Okay, so this is the cofactor. Let me change its color, which acts on this step. And also there is another cofactor which acts on this step, where the factor 10A will activate prothrombin, and that is factor 5. So activated factor 5A. So there are two cofactors on the coagulation cascade, factor 8 and factor 5. And also these steps that I'm marking in red here, so all these steps, okay, so this one, then the extrinsic pathway, this and these steps, they require calcium and phospholipid. Okay, so these steps that are marked in red require calcium and phospholipid for their activation. And then these clotting factors that I'm highlighting in green, factor 9, factor 10, factor 2, that's prothrombin, and then the factor 7. So these clotting factors are vitamin K dependent clotting factors. Okay, so there will be deficiency of these factors when there is deficiency of vitamin K, or when there is some kind of liver disease. Also, deficiency of factor 8 is called hemophilia A. Deficiency of factor 9 is hemophilia B, and deficiency of factor 11 is hemophilia C. So factor 8 is A, 9 is B, and deficiency of factor 11 is hemophilia C. Popular drugs such as heparin, or low molecular weight heparin, these drugs, they inhibit thrombin as well as the activated factor 10. Okay, so heparin along with low molecular weight heparin will inhibit thrombin and factor 10. Then there is another drug which is a direct factor 10A inhibitor called apixaban. This drug will directly inhibit factor 10A. And also there is another drug called fondaparinux, which is just a synthetic form of low molecular weight heparin, will also inhibit factor 10A. And then we have direct thrombin inhibitor drugs such as argatroban and dabigatran. So these are direct thrombin inhibitors, and they will inhibit the thrombin. And coming down here, at the end we have formed a stabilized fibrin mesh. After the healing is done, this fibrin mesh is degraded into fibrin degradation products by a protein called plasmin. So plasmin is the factor that will destroy this fibrin mesh. It is an activated form of plasminogen. So plasminogen gets activated to plasmin, which will destroy the fibrin mesh. And this activation process here is done by TPA, or tissue plasminogen activator. So tissue plasminogen activator will activate plasminogen into plasmin, and then plasmin will destroy the fibrin mesh. This TPA is actually stimulated. Here, it's actually stimulated by certain drugs such as streptokinase, tenecteplase, altiplase, retiplase. These are drugs that are commonly used in stroke, ischemic stroke. So these drugs, stroke and MI, okay. So these drugs will stimulate the tissue plasminogen activator, and then they will cause the degradation of the fibrin mesh. Also, this tissue plasminogen activator is inhibited by other drugs such as tranexamic acid. So tranexamic acid will inhibit this step, inhibit the activation of plasmin, and this will cause less bleeding. Okay, so we give tranexamic acid post surgery to cause less bleeding. Also, there are certain regulatory proteins called protein C and protein S. So these are the regulatory anticoagulant proteins which cause anticoagulation by inhibiting the cofactors, which is factor 8 and then factor 5. So these regulatory proteins called protein C and protein S will inhibit factor 8 and factor 5. So that's with the coagulation cascade. Thank you.